Does anybody have any questions?
Hi, Annie DeGroot from Epivex. I have two questions. One for the last speaker, Jack, right? If you increase the reactivity or the potential immune response to infections, are you at all concerned about the corollary, which would be increased autoimmune disease?
That's a very good point. Bonnie Millard, who's developed these high immune response lines, for her PhD at the University of Guelph, she actually had selection lines in pigs, actually, where she selected on an index of immune measures. And she did find, indeed, that the high immune response line had a higher level of autoimmune diseases, arthritis particularly. And so that's something that we have to worry about. The thing is that a breeding company is not, so that was single trait selection on the index of immune response. A breeding company is never going to do single trait selection on immune response. It's always going to be growth rate, back fat, reproduction along with immune response. So it's something that we have to be monitoring, but I don't think it's an immediate concern.
And there was also a selection for the class 2 antigens in that very early, the second generation. So, and that's something that a breeding company would avoid.
Okay. Related to class 2, actually, I have a question for Jay, which is, when you're selecting your vaccine strains, you're kind of going through this process of, can you actually produce it? Does it grow in the right cell line, et cetera? This is the attenuated strain. Do you think that you could introduce a Tcell epitope or B-cell epitope feature there so you could actually select a strain for increased presence of T-cell epitopes that would be cross-reactive, for example? Do you think that would be a useful feature of selection for vaccines? Of course, this is a leading question, as you know.
Yeah. Interesting idea, Annie. I think it could be done, but to do it would take an infectious clone, which we can do, but that would make the resulting vaccine a GMO, which would take more time to register. Yeah.
Any more questions right here?
So my name is Gyula Balka from Budapest, Hungary, University of Veterinary Medicine. I also have two questions. First to Andrea Wilson, and you have already partially addressed this question in one of your slides, but I didn't really heard the answer in the end, that based on your research and maybe your personal opinion, this rebound is for sure it's coming from the animals, so is it internal or maybe from others, like those super spreaders or something? What's your opinion on this?
I don't know. So, what we wanted to challenge, so when we found the heritability is 0 for rebound, the first conclusion you would jump on, it has nothing to do with the host, the genetics. So you would assume, because the immune response is driven by host genetics, that you would expect that rebound, so that if you find a genetic component, it's through the immune response. So the first thing was to actually disprove the hypothesis that the host plays no role in it. And I think, so this we succeeded to disprove the host clearly would have a role in rebound. And of course it would, because it would then select the different, because the PRRS is so variable. So it has to somehow be a part of the host. Now, how it's related to infectivity, for example, or I think it's fair to say it doesn't come through reinfection of the host, because it was just so quick with this nursery challenge model. So it is probably something coming within the host, but how it's then related to spreading of the virus, we have no idea. And this is really something to test. Are these rebounders also really then shedding it again? We don't know. Did that answer your question?
So you think it's from an internal source, kind of? So definitely not from...
It's how the host interacts with the immune response. And maybe, Bob, yes, you may have some more.
Yeah, so Susan Carpenter is a virologist in our department. She's now retired, but she, one of her PhD students looked at the virus samples from the different from a couple of pigs, different time points, and she found evidence of selective pressure, and that the escape virus was different than the inoculant. Now, that still doesn't mean that there may not be a host response involved, because the amount of selection pressure will depend on how effective the immune response is. But there was some evidence that there was that the virus escaped the immune system.
Maybe in the next challenge study you should just separate the pigs and keep them individually to see whether it happens or not. My second question is to Jay Covert. You said that attenuation that has been done in case of the other vaccines, you said that the adaptation of those strains to this monkey cell line is dependent on adaptation to monkey CD163 receptor. So can you a little bit talk about a bit more about this, because that's kind of outstanding data. It means that the change the virus gains is mostly on the GP2, 2A3, 4 complex, and I would assume that in this case there should be lower levels of viremia after vaccination, but we don't really see that. I mean, in these slides we saw basically equal levels. Can you comment on this? Thank you.
Sure, and that last point about the viremia after vaccination is difficult to understand, but we do know that if you, and you can do this, you can titrate some MA104 attenuated virus on macrophages, primary macrophages, and I think you're going to find that the titer is very, very low, but if you titer the same virus on MA104 cells, you'll get a nice, healthy, normal vaccine titer. That's in contrast to our vaccines, which actually give a higher titer on macrophages than they do on their natural adapted cell line, which is the hamster cell line. So we do know that the virus during adaptation does lose its ability to infect, not completely, but by 2 or 3 logs, loses the ability to infect macrophages, primary macrophages. We assume that's true in the pig. But you're right, it does replicate in the pig. And my best guess is that even at 1% or less infection, normal infection rate, the virus is infecting enough macrophages to create a viremia that's detectable in the serum. But I've looked at those viruses coming out, and they have initially, at least up to 10 days, have the same phenotype as the starting vaccine. If you titer them on monkey cells, you can see the virus. If you titer them on macrophages, it's not there, right? Now, over time, I think the field shows that over time, it may take more than one passage in pigs, but those viruses will adapt to be able to infect macrophages more readily. And sometimes vaccine-like virus isolated from the field actually grows quite well in macrophages. So that phenotype changes. Thanks for the question.
Good. Any more questions? Back there.
I'm JQ from Iowa State. I have 2 questions. First, to Andrew Wilson. So you mentioned that there's a viremia rebound and a non-rebound pigs. So my question is, for those viremia non-rebound pigs, eventually there's no viremia, but do you know if those pigs also is a tonsil free of virus? So those pigs still have virus in tonsils or not?
Possibly, I don't know. It would be really good to look at it. We didn't have this data, and the model we've chosen also, it doesn't, it's only one it's an infection site, it's in the lung, so the model can't answer it. So we don't know. Good question.
Okay, the second question to Dr. Jack
And
Decker.
can I just add that we've done we've been looking at the amount of virus in the tonsil and looking for that, but we haven't done a correlation of whether that's associated with rebound. That's something we need to do.
Yeah, because I personally did some study a number of years ago, So, of course, it's a very low number of pigs, only 20 pigs in a group, So some became viremia negative after around, I believe, 49 days. But some still, viremia positive. But up to 63 days, all of those are still the virus are positive in tonsils, So.
Yeah. Well, and we showed, and what you've seen in other data, that you'll have it's more likely to have no virus in the tonsil if the serum level of virus is 0. But you can still have many animals that have no virus in the serum and yet significant virus in the tonsil.
Mm-hmm. Okay, the second question to Dr. Jacob Decker. So you mentioned that after vaccination, if the low levels of vaccine viremia tended to be more resistant after challenge, the low level viremia after challenge. Right? So question is, after vaccination for those pigs with low level viremia, did you observe the stronger immune response compared to those pigs with a higher level viremia?
We just recently received antibody data from Maureen and Bob, but we haven't had a chance to look at it yet. But we will be able to answer that question. It's a good question.
That one's on me.
But you can also look at the gene expression data, and you saw that for certain genes, you could see higher level of expression after the challenge, and others you didn't. So there's that data as well.
I think just to make a quick observation, I don't know if Jeff Zimmerman is still here, but when we did the first big pig study, infecting 100 pigs for a very long period of time, and just doing the IDEX ELISA, it was never flat. It seemed to go up and down, and we'd see these waves of increased antibody response. And we kind of thought, well, why is that? Why isn't it just steady? And so we thought that maybe virus is actually coming back, over a long period of time. A question over here. I can't see you because the lights are in my eyes, but Vlad can.
I'm Minzhou from Northwest AF University in China. I have a question for Dr. J. Calvert. So we all agree with that CD163 is indispensable for PRRS infection. Yep. But for your study, for the monkey cell line and PAM cells for passage or vaccine virus, you saw there was that because of the CD163 on monkey origin and swine are different. So do you agree there's maybe another or other receptors rather than the CD163 play also roles in the determining the virus growth on the monkey cell line versus swine? If you agree, what do you think the other receptors and factors? If you don't agree, then you don't need to answer the question. Thank you.
Maybe I'll take the easy way out. No. No, I think there certainly are probably other receptors, sial adhesion or Siglec or CD169 being a very good candidate. It does not seem, though, to be the limiting factor because we're able to convert several different totally non-permissive cells to permissivity for PRRS just with CD163 by itself. We tried adding in sial adhesion to see if it helped, and it didn't make any difference at all. And then there's the genetic data in pigs that if you knock out sial adhesion, you really don't have an effect on virus growth. But if you knock out CD163, you get completely resistant pigs to PRRS. So, and there are other probable proteins, many of them if you think. Anything that binds to the virus or the virus proteins or envelopes and is involved in the process of internalization and uncoating, it can be called a receptor. And there's probably multiple cellular proteins that do that, but they don't seem to be the gatekeeper, the one that's making the difference between being permissive and non-permissive.
Thank you.
Yeah, I think if you were to, my understanding is that for all the cell lines that you've tried, regardless of the mammalian species, you add CD163 and they become permissive.
That's right, Bob. And we've done, well, less than half a dozen, but all the ones we've done have worked. You know, I haven't had to add anything else. In the case of the PK cells, we actually looked for expression of CD163 after we added it back in, and there it was. We also looked for expression of cell adhesion. We couldn't detect any.
Yeah.
So in those porcine kidney cells, we weren't getting any cell adhesion and yet they were permissive.
So I think if there are co-receptors, is that they're likely, maybe if they are there, they're highly conserved across, you know, all mammalian species, and so they're probably pretty promiscuous, you know.
Yeah.
Any more questions? Yes. Go ahead. Oh.
So when we vaccinate pigs in the field, we'll oftentimes get a percentage of pigs that never seroconvert.
Yeah.
So you vaccinate 100 pigs, you may be like 96% seroconversion. Is it possible those pigs just aren't allowing the virus to grow once it comes back into the pig? Or is that just something else that's making those pigs never seroconvert?
That's a good question, Paul. We're not quite sure what happens with those non-responders. Usually, the ELISA is a pretty good indicator of whether the vaccine took, you know. But when we do the studies, even groups that have non-responders tend to see a significant difference from non-vaccinates, for what that's worth. It is maternal antibody can neutralize vaccine virus, and as you go younger in age, it becomes more of a problem. So with the one-day-old claim, a lot of it is being creative and experimenting, see what works in a particular case. Maybe one day is too early with maternal antibody. Maybe processing is better, or maybe just 1 week before weaning is the best time to vaccinate.
And those studies that we've done were negative pigs, so they shouldn't have had any maternal antibody.
But the other thing is antibody may not be the only thing that predicts protection, so that you would figure certain interferons and innate immune responses, cell-mediated responses, would potentially reveal that they had a reaction to the vaccine. It's just not antibody.
We like antibody because we can measure it.
Was there PCR, virus PCR, or you don't know in that case?
We didn't do the pigs individually, so I don't know that. Yep.
But I think that would be the type of data that would be very interesting from a host genetics perspective also.
Just seen it too many times.
Yeah. Any more questions? I guess the one burning question is that very early on we identified WUR as a favorable marker, and all the presentations and all the studies seem to continually bear that out. Why isn't it in the industry? Why don't we have it? I mean, the whole idea of doing translational genomics is to take this so that Polyeski doesn't have to worry about PRRS anymore. So where are we at with the WUR marker?
Well, we should ask the breeding companies, but and I don't know whether some of them are using it. They don't tell me everything. But we have shown, one of the studies that Janelle Dunkelberger did, she spent several months in the Netherlands with Topics, Swine, and showed that, so one of the concerns is, well, maybe the B allele under clean, without disease, hurts production. But she was able to show that across multiple lines, there was no correlation with the overall index that they select on. So it didn't seem to have a negative effect. But the concern is that the B allele, which is the favorable allele, actually has a fairly low frequency in most lines, most breeding lines, which raises the question, is there something about this allele that hurts performance in one way or another? My explanation always is that the reason why it hasn't been selected for is because selection takes place without disease. So the reason why it may not be higher than it is because breeding companies don't select for growth or litter size under PRRS. It's without PRRS. But it's still, there's still that lingering question. Yeah. And it's a sizable effect, but it's still only 15% of the genetic variation, so it's not the...
Good. Any more questions? I think with that we can conclude this session. Again, I want to thank all the speakers and especially the audience for your patience and for your questions. Thank you.